So we are a company called Datazip. We are creating a product called OLake, which helps people to basically get their data into the Iceberg. It's a simple EL tool. So today I'm going to talk about reimagining Iceberg ingestion. Quick introduction is I have 9 years. I've been working 9 years as a data engineer across India and across the globe as well. So today I'll be talking about three main problems that we found after interacting with almost 150 customers. So the first problem is scale. So the scale as a problem, it's basically like Iceberg as a technology. It's supposed to be like an enterprise scale. Usually the enterprise scale usually looks like terabytes to petabytes. And what we have seen in the current ingestion tool or the market is the tools like Fivetran or Airbyte, they are usually catering to almost like a half a terabyte or a quarter of terabyte averagely per customer. And these are the real numbers. Like one of the primary reasons that I have seen this happening is because these tools are almost half a decade or a decade old. These tools are also they were designed at the era when warehouses were the dominant processing layer. So dominant processing layer, as in like there is a server sitting behind which is continuously taking the data in, compacting the data, and optimizing the data for the queries, right? But on the other hand side, like let's say Iceberg is not something which you there is a server where it's running continuously as a process and compacting data, optimizing it, right? So first thing is the scale is really different, and the way you ingest the data into the Iceberg is really different. And for the sake of the people who are new to Iceberg is an open Lakehouse format. It's basically one of the great capabilities of Iceberg is you can ingest the data into the Iceberg, and then there is no vendor lock-in as such, right? Basically you can query it using any other query engine for the people who are just new. So one of the other things that with the existing ingestion solutions out there in the market is they were too generic in a nature, like in the sense that they were designed to cater to M sources and then end destinations, right? Which is one of the problem, because I think Iceberg is it's standalone sort of a format which needs a lot of optimizations or innovation while you're writing itself. So and also Iceberg has its own data types, scheme evolution strategies, and all of that, which you need to cater to. So for a generic tool like all the other managed DL solutions that you find here, they lack a lot of Iceberg specific optimization, right? And the final one is basically what are the high volume sources that we see here today in the industry? There are databases, Kafka event, or already sitting data in your S3. So these are one of the highest volume sources that we have talked to when we did like almost 150 discoveries. We talked to a lot of enterprises, a lot of SMBs here in India and US, and then we realized that these are the highest volume sources that enterprises or SMBs are catering to. And what we have seen is the scale where Iceberg operates. So we were talking to one of the companies, one of the co-founders of a really popular EL solution in the past, and they were really focused on Iceberg. They got acquired recently. So the second highest customer of them was actually transferring or throughputing more data compared to all the 9,000 customers that Fivetran has, right? So yeah, that's what the scale that we are looking at. Second problem with Iceberg adoption that we see is, and this is a generic problem. I'm not saying like this is something related to ingestion, but it's more like a people who are trying to adopt to Iceberg, they are facing this. So the Iceberg adoption has been a little slower. Like when we talk to these 150 companies, what we realized is only 15 to 20% companies are actually moving towards Iceberg adoption. And that's the number that is a little lesser than what we have expected, because we thought that like Iceberg is the next cool thing and everybody is on top of their mind to move to Iceberg, but it's not, right? And there are multiple reasons to it, right? For data engineers like me and all the other data engineers, it's one of the coolest technology that we have ever seen. It's that industry changing technology that happened once in a while, right? For example, a decade back, Snowflake was invented. Storage compute separation was one of the coolest things back then. But the problem with Iceberg is it just like there is no single vendor today in the Iceberg ecosystem which manages everything for Iceberg. For example, in Delta, which was again invented by Databricks, if you're using Delta, you can basically kind of you have that in your back of your mind that even if I mess something up, there is a company behind which I can move to and get everything managed, right? Apart from that, there are a couple of other things as well in Iceberg adoption space. Multiple tools and lack of knowledge around every step that goes into Iceberg, creating Iceberg Lakehouses, right? I'll talk about the ecosystem as well, the tools that I was talking about. So to get the Iceberg pipelines right, you need to assemble 5 to 7 tools. And in those 5 to 7 tools, there are a couple of them for the ingestion. There is a couple of them for the observability and optimizations. Then there are a couple of them for the governance and cataloging. And then transformations and query engines are the other side of the thing that I'm not even going into, right? So when we actually just even think about ingestion as a solution, so we need, like, the current existing solutions out there, which are really popular, or people have been using them for a while, is Spark, Flink, Debezium, Kafka. All of them are like kind of JVM designed decade back or a half a decade back, mostly 1.5 decades back actually, all of them. So and they require a lot of engineering overhead. So even if you just want to set up a simple CDC pipeline, Debezium, Kafka, and then Kafka Connect, or Debezium, Flink, and then like couple of other things, right? So they require a lot of engineering overhead. So I'll tell you an example. Back in 2020, we were one of the first adopters of Lakehouses as a technology. We adopted Hoodie back in Pepe, right? And at that point, we, as a team of 10 data engineers, 3 or 4 out of us were just constantly working on optimizing the pipelines. And like literally we kind of gave the presentation to the whole company when we were able to achieve like less than 10 minutes. So it was a big achievement back then. So, and then you need to go an extra mile for just partitioning, ordering, schema evolution, and filtering if you're designing these pipelines using these existing tools, right? And apart from that, once you use those existing tools, you also have to do the table optimization, which means that whenever you're ingesting, if you ingest every 1 minute, 2 minutes, 5 minutes, you are creating too small of a files. Then you need to basically run one more job of table compaction, deleting orphan files, snapshot management, because Iceberg also support time travel, right? So you also have to delete the snapshot which are way older, otherwise they will be keep on hogging to the S3 costs. So that's the problems with Iceberg adoption that we have particularly seen talking to so many companies. Then finally, the last problem that I'll be talking about is the legacy to Iceberg kind of migration. So legacy, what do I mean by legacy is, there are a lot of companies, especially like banks or some level of enterprises where the data platform is running for last 20 years or 15 years. They have designed their data stack, especially in the likes of Spark plus HDFS, or Spark plus S3, or Hive plus S3, or Hive plus HDFS, right? The legacy ones. So for them, it's an obvious choice or obvious kind of a way for them, because there are direct benefits if they migrate to Iceberg, right? But trust me on this, we have talked to many companies out there and they have petabytes of data sitting like this, especially the banks or companies which are like 50 years old. So for them, the migration actually means that they have to move that petabytes of data using a copy. But that's too much of effort. They don't want to do that, right? What they want is if let's say that data that has been sitting there in their Hive or HDFS or wherever, if they can generate some sort of a metadata layer on top of it and then make it Iceberg compatible without moving a zero data, right? That's what they want. So like Iceberg, if you think about it in a fundamental way, it's just a Parquet sitting on your blob storage, and then there is a metadata layer and the catalog on top of it. So if you can generate that metadata layer and create that catalog, you're making your Hive or kind of HDFS Lakehouses already compatible with Iceberg. You can actually query using the Iceberg endpoints. So they want this kind of a solution, but this also requires too much orchestration. So we were reading a really great blog by Netflix. I was reading like a couple of months back. Netflix did this exact thing. They were previously on the similar structure. So what they did is they first had to kind of create that metadata layer, also make sure that the metadata layer is in the sync as you ingest the more data in your previous Lakehouse format. And then eventually they migrated all of their workloads queries to the new Iceberg related query formats. And then eventually they kind of cut off the older Hive thing and then fully migrated to Iceberg, right? But this requires too much of an effort. Like they actually created 3 or 4 smaller tools and they open sourced it as well before. And for each of these process, like to make it in the sync, then cut off the older and all of that. So this is the third problem that we have seen. As I talked about, one of the highest sources of data is already the data sitting in the S3 or object storage. So if I have to think about today, like how would I design an ingestion solution, even if I'm designing it from the scratch, or if I myself like creating a product for it, right? So it has to have a high throughput, as I mentioned. Iceberg is not for gigabytes, so don't even think about like trying to implement Iceberg for if you have less than a 1 or 2 terabytes of data. It will be just too much of an engineering overhead, at least today, right? So it needs to have a high throughput. Second, it needs to be lightweight and scalable. So if you can avoid the Spark, Debezium, Kafka thing, that would be awesome, right? It needs to have, especially if you're catering to the databases, we need to have full load, incremental with a bookmark kind of a column, or CDC. All the three methods of the data sync, right? And let's say, as I mentioned, it has to be Iceberg specific. We have to support all the catalogs out there. The new spec Iceberg is throwing every other year, right? Apart from that, it has to handle the schema evolution and table evolution as well, which is specific to Iceberg, right? And now what do I mean by that? So schema evolution, I'll talk about a bit, right? In terms of Iceberg, the schema evolution has three things. One is the widening of the type. Iceberg supports usual widening of the types, which is from int to long, and then basically float to double, and then there are decimal points things, right? But we can also do one another thing, which is lowering of the types. So a lot of companies who are dealing with semi-structured data, imagine if your data was already coming in a higher type, which is like string, and then you start ingesting data, but out of nowhere your developer changed it to something like maybe int or something like array of JSON, right? So you don't necessarily need to break the sync. If the higher data type is string, you can still accommodate the newer data that's coming in into the same column, right? So it's called lowering of the data type. So you can also handle that. Apart from that, there is a parsing thing. So if your data is coming into, let's say, int, but now suddenly somebody changed it to the string, especially it happens when you're dealing with MongoDB, DynamoDB, or Kafka kind of a thing. So you can actually try to see if you can parse the data, and if it's not compatible with the already existing type in the Iceberg column, right? You can parse the data and see if it's still compatible with that type. And if it is, then dump it, otherwise fail the sync or put it into the DL queue, right? Dead letter queue. So that is one. Apart from that, there is one another thing that we have realized while we are talking to the clients is, especially in the case of Debezium kind of a thing, imagine you have 20 tables you are already syncing, right? And tomorrow you have to add 2 more tables. So like a lot of people have explained to me that, for Debezium to add 2 more tables, they will have to wait for the full snapshot of those 2 tables to complete, and then only the CDC or the incremental would continue, right? But there are ways to avoid it, Debezium as well. But people, like we have talked to many data engineers, a lot of them have complained about it. So the new table additions, or it has to be really smoother, because in case of Iceberg, we are dealing with the tables of size of half a terabytes to a couple of terabytes, right? So we cannot wait for our CDC syncs to stall, because it would cause the metadata bloat, right? So that's there. And then it's obvious, I have to say that like your syncs has to be resumable, even if you're doing a historical snapshot, right? You have to have that capability to resume where you have left off. So these are the capabilities that we have gotten after talking to a lot of people. Then we started thinking about it, and we started taking examples of all the popular databases out there, like MongoDB, MySQL, Postgres, Oracle. So one thing that we have realized is, while we are doing the historical snapshot of the data, we have to split the tables into smaller chunks, and these smaller chunks has to be processed parallelly, right? And then we researched about it, like how we can actually split the tables into parallel chunks. A lot of these databases have really cool strategies around it. For example, MongoDB has split vector and bucket auto strategies. Postgres has CTID kind of a strategies. You can actually split the table, which is, let's say, a terabyte big. You can actually split it into the chunks of 20 GB, 15 GB, and then sync those chunks parallelly, right? Apart from this, like whenever we are chunking these tables, we have to make sure that the chunks that we are creating are going to result into an optimal file size at the Iceberg side. So now what do I mean by that? Like if I create a chunk of 15 GB, it is more or less going to result into a couple of 500 GB files, 500 MB files, into the Iceberg, right? Because Parquet compresses the data. So that's there, right? Again, after that, as I mentioned, right, to avoid the CDC bloat while you're doing a full load or historical load of the big table, you have to process the CDC in the parallel as well, so that your metrics are not stalled waiting for that one big table to do the full load if you add the table later onwards. So we need to have a watermarking strategy while we are ingesting from the databases. There is a really good blog about watermarking which is published by Debezium a while back. You can actually read about it. So, and then as I mentioned, right, whenever your full load, if couple of you have processed 500 chunks out of 1000, when you start the full load or the historical snapshot again, it should start from those 500 remaining chunks only. It should not process the previous half of the table, which is already kind of done. So apart from this, there are a couple of innovations that we have to do while we are writing to Iceberg. This is what I was talking about in the first slide, right? So Iceberg is, end of the day, it's just a parquet. So we can actually use Arrow to write into Iceberg. Arrow, for the people who are not aware, Arrow is a technology which is like an in-memory columnar format. And the reason why Arrow is fast is because that you get that data into your in-memory columnar format, and you dump it into the parquet as a columnar format. So that dump from columnar to columnar is pretty fast, right? And it also takes a lesser memory compared to the existing. If you just simply use the Java API for Iceberg, we have actually done a good benchmarking on this. Apart from that, while you're writing to Iceberg, there is one really cool technique that we are actually thinking of experimenting, and we have done some mathematical modeling around it. So there is a lightweight compaction. So what do I mean by lightweight compaction is, while you're writing the data, if you're syncing it anything lesser than a couple of minute frequency, you would be end up creating really smaller files into the Iceberg side. So then that's what's called a small file problem. So while we are writing the data, can we actually take this couple of 100 KB files and couple of MB files, single digit MB files, and at the time of write itself, we can merge and we can write, right? That would have a significant impact on your query performance, number one. Number two, you would have to, basically you would have to do 2 or 3 times lesser bigger compactions or the main compactions compared to if you don't have a lightweight compaction while writing. So that's one of the cool optimization that we can actually do. And apart from that, there is a exactly once delivery. I don't have to talk about this a lot, because if you don't have it, you will have to end up creating one more sort of a medallion layer where you just deduplicate the data from going from raw to bronze. Apart from this, I have had one of the cool talks last time I was in New York. So one of the people from AWS, they gave a talk on a project called DeltaCat. So they have open sourced a project called DeltaCat, which was really doing a cool technique. So while you dump the data into the Iceberg, there are 2 ways to dump the data into MOR format, right? We have all of here probably heard of MOR versus COW, right? So in MOR, equality and the positional deletes. So equality deletes is it's like I want this data to be replaced by this copy, and positional delete is like I want this data to be replaced at this file at this location. So usually equality is more faster in terms of writing, but slower in terms of reading. Positional is more faster in terms of reading, which most of us want, right? We have our lake houses to read more than writes. But the problem is, if you write it into positional, you would have to basically run a Spark job which scans all the files in the partition and then write, which takes huge amount of time. So a lot of people who have a SLA requirement or the sync frequency requirement, they choose to write it into equality deletes, right? If they want to have their data 5 minutes fresher or couple of minutes fresher, right? So but one of the cool techniques is, what if we write the data into equality, and then in parallel our writing engine actually can run a background job to convert these equality files into positional files, so that couple of initial queries would be slower, but eventually after that your next queries would be much faster if you have that positional, if you have converted it to positional deletes. So all of these innovations are possible while we are actually choosing Iceberg as a destination, right? So with that, all of these optimizations that I have talked in the previous slides in mind, we are creating an open source tool called OLake. So OLake is nothing but fastest way to get your data from your databases and Kafka kind of a sources into Iceberg. We are fully open source, Apache 2 license. We have started this project almost 8 months back, and we have got a good response in terms of we are already 1100 stars. We have written the full engine, OLake engine in terms of Golang. We have not chosen the JVM and the previous overhead engines. We are not using Debezium. We have written fully the CDC kind of a things ourselves. Apart from that, we also have Kafka coming in. We are going to launch Kafka as a source in next 1 or 2 weeks. We have launched a simple UI so that if you have hundreds of tables, we can simply select the table, simply select the sync modes, simply select the cursors and all of that. It's a pretty simple UI. So you have multiple deployment options. You can deploy it on a simple EC2 using Docker Compose. You can also deploy it using Helm if you want some level of production level SLAs. And then eventually, we are also thinking of this Hive to Iceberg zero copy migration. But as of now, we have not started this up. We are still looking for some design partners for this. So if you're looking for the Hive kind of a solution, happy to talk to you. So basic architecture with OLake looks like is you have all the sources on the left here, and then OLake sits in between, and then we can either dump the data into the Parquets or we can dump the data into the Iceberg. So one of the cool way the companies are using us, right? They're using all of these sources using OLake and then dump the data into the AWS S3 tables, so that the whole pipeline becomes really self-sufficient. S3 table take care of the compaction and all the other things. OLake takes care of the fast ingestion, and with that you can actually query that using any query engine you want. Could be like Snowflake or Athena or DuckDB, right? So yeah, we have recently revamped our statistics. We as a product, as I mentioned about the throughput, we had to excel in that, right? So we basically compared ourselves with all the industry tools that people usually use. So Fivetran, we synced almost NYC taxi dataset, which has 4 billion rows. We were able to sync the data in with the 2.35 lakh RPS. Apart from this, the Fivetran was there, which took about 46,000 RPS, which was the closest one. Then there was a Debezium. So there's a really good project by Memizo. He basically used Debezium and kind of get the data from databases and directly dump into the Iceberg. So we compared it against that. We are almost 16 times faster. And then there were a couple of other tools as well. And especially like in terms of CDC, we were almost 36,000, 37,000 RPS. Nearest was the Fivetran, which is 27,000. So, and as you can see the other numbers, right? So the future roadmap that we have today is, as I mentioned, we are going to launch the Kafka in next 1 or 2 weeks. We definitely have observability and monitoring requirements. So we're going to work on that, especially if you want to get notified when your sync fails, or you want to see how your throughput is doing, what are the statistics, real-time metrics. And apart from that upcoming feature, we have a lot of good upcoming features coming up. This is something, the first point I would like to highlight in a minute. So continuous mode, right? So what we have realized after talking to so many people and having like attended so many conferences around the Iceberg is technology which is not that great at streaming. Like when you write sub-second data, it's not good, being honest, right? So what it's actually good at is a continuous mode. So you have a batch on the right side, you have a streaming on the left side. Iceberg is actually good in between, right? Which is a continuous batch or continuous, mode, whatever you want to call it. So with this, what do we do is we basically tell that, for like wait for a couple of minutes or wait for a minute before you write, gather all the data while you're getting that in a minute and then write. Or otherwise we can tell that, maybe create at least 20 MB file and then write. So don't write like KB files. We at least have to write some data which is gathered, right? That is there. And this we have gotten a request from a lot of people to add this into the product. Apart from that, there is a heartbeat mechanism. This is again for the avoiding the wall bloat. This feature has been there in Debezium for a good amount of time. Then there is a partition evolution and sorting while writing. So we recently hosted Amit, who is a co-founder of a company called Lakehouse. He was basically talking about this recently. So if you write your data sort in a sorted order while writing, so basically your query performance is actually 50% faster, right? So that is something that we have gotten as a request. Then there is a lightweight compaction, which I just talked about. And then there is a query optimization via clustering, right? So clustering is another technique in Iceberg side. If you do clustering and if you have the data which is not a time series kind of a data, you're an e-commerce company which gets most of your data in last 4 months of the year, right? For them, the clustering works really well. It distributes the data into proper clusters so that it's more faster. So that is the future roadmap that we have. We are fully focused on Iceberg and getting the Iceberg optimized, right? It's not just we are contributing to our own open source project, we are also contributing back to the Iceberg. So recently one of the team member, he contributed a partitioning PR into Iceberg. Iceberg Go. So if you don't know, Iceberg has multiple flavors: Iceberg Java, Iceberg Go, Iceberg other flavors. So we have added this big feature of partitioning rights into Iceberg Go, and as well as a couple of other features we are trying to contribute in the future, which is missing catalog supports and equality deletes, right, into Iceberg Go. So as a quick traction thing, I'll just skip this really quick. We are just an 8 months old, but we have already reached 1100 stars. we are faster than most of the tools out there, or DLT Hub or History to reach this milestone. But we are still new to the market. Like we are actually improving a lot on Iceberg side of the things. A lot of good data engineers are trying us out. Like a lot of good companies in US and in India as well. They're giving us a try. Some of them are also running us in production with the good scale, right? Yeah. So if you're interested, definitely scan our project, and I'm happy to take question and answers right now or even at the later point in time, if hosts allow me.